Hello everybody, welcome again to another Henstitute help video. This one we're going to look at density and Archimedes principle, problems number 5 and 6. These are still both dealing with the density equation. Since the first one, actually number 5, deals with gold, I went ahead and put the equation here for the density of gold, 19,300. The density of water, which we had earlier, which we're going to need for problem number 6, um, is just that 1,000 kilograms per cubic meter. So remembering that density is mass divided by volume, that's all we have to kind of go about this. But 5 goes through a series of things. It says you've got a bar of gold that measures these dimensions. So basically if I multiply those three numbers, I can get the volume of my bar of gold, but it wants to know how many gallons of water have the same mass as this bar. Okay, so here's how I'm going to tackle it. The first thing is let's just go ahead and figure out this volume. So I'm going to take 0.15 times 0.05 times 0.05. Okay, so that gives me a really small volume. And you're actually going to find most of the volumes in cubic meters are going to be really small. So 3.75 times 10 to the minus 4 cubic meters. Okay, now borrowing this equation down here, we know that mass would actually equal density multiplied by volume. So we want the number of gallons of water to have the same mass as this bar. So here's the way I'm going to kind of think of it is we basically need the density of our gold times this volume that we just found, this volume of gold, should equal, and I'm going to change the color here, the density of water, which we just wrote over here, times the volume of water. So what we're going to try to do is we're going to actually try to solve for that volume of water. Now, when we do that, you're actually going to get cubic meters, not gallons. So your last step, once you get this value, you'll get the volume in cubic meters. You're going to have to convert this into gallons. But there is actually a conversion on your conversion sheet that'll take it into gallons. It's like 260 something. I forget exactly the number. I don't have it in front of me. And that'll just change it. You'll be able to multiply it and you'll figure it out pretty quick. So the idea is if you had this bar of gold and a container of water, what would be the volume of the water is really what you're trying to figure out that would have that same mass. Number 6 is kind of a weird one. You've got the information about the sun and then information about Saturn. So, and they keep talking about density. First off, we're going to treat the sun and Saturn as spheres. So one of the things we need is the equation for the volume of a sphere. Again, this is information that I assume you'll look up, or we will probably talk about it more later and maybe add this to our equation card. So the volume of a sphere is 4/3 pi r cubed. So in the first one, it says the mass and radius of the sun are these values. What is its density? So we're basically going to use the density equation. We're going to take the mass of the sun divided by, and I'm just going to put this equation in. So it's going to be 4/3 pi r cubed. So they give us the radius of the sun and its mass, and we just plug those in. Then B, if a solid object is made from a material that has the same density as the sun, would it sink or float in water, and why? So once we calculate this value, this is going to be in kilograms per cubic meter. The idea of sinking or floating is, are you more dense or less dense than the fluid you are in? When we talk about Archimedes' principle and the buoyant force, that's another way to think of it. But the easy way here to deal with density is just to think of, hey, is it more dense or less dense than water in this case? So the idea is if you had a material that had the same density as the sun, you put it in water, what would happen? So once you figure out this value for part A, you're just going to compare it to 1,000. If it's greater than 1,000, it would sink. If it's less than 1,000, it's going to float. You will actually be probably amazed of the density that you get. At least I think you will. knowing that the sun is made out of mostly hydrogen and helium, you have to also take into account that gravity pulls it into a much denser um, system than we expect. And then C, would a solid object sink or float in water if it were made from a material whose density, please provide this density, was the same as that of the planet Saturn? So they do the exact same thing. You're going to calculate the kilograms per cubic meter, put the density on there for C, and then tell me whether it sinks or floats. And I do that with Saturn because Saturn happens to be one of the gas giants, just to kind of see how that fits. Hope that helps.